tools we currently have, it really doesn't get much better than this. You get recommendations, because just the seller, the server, can only guess. And maybe you just don't want any of these things. And if you do, it was a good recommendation, and there's a lot of money and effort invested in more and more accurately guess what you could like. But we just thought it somehow inefficient. And well, if that's not motivation enough, let me tell you about some vacation that I made some time ago with 7 friends. We were going kitesurfing, to Egypt. That was the idea. Or actually, that wasn't the idea at the beginning, but at the beginning we knew there was one beginner, there were 2 experts, some people needed to rent material, some people wanted to do something cultural, it wasn't that important, and so on. And then you get the picture. Everybody, I think, has done this before. So you have to plan a vacation that satisfies all or many of these needs. And then you come up with like 3 suggestions, and you email them to everyone, and then, I don't know, people take 2 weeks to decide, and everything you looked up maybe isn't available anymore, or the prices changed, or something came up, so you have to do everything again, the whole research. And this is kind of inefficient, although the web has brought the whole marketplace, the whole world as a marketplace, right to our fingertips. Still, it's not very efficient. The problem, as we see it, is this. We don't know what people need. And it's actually, in this situation, unfortunate, but on the web we can change it. We can just publish a document that says, I want this, in this case, the candy bar. And the opposite side can do the same and publish similar intention. And these 2 documents now sit on the web, now just in this form. May not be that interesting, but if you add just one more ingredient, an independent matching system, matches can be made and connections can be made, so that I can then ask and maybe get the thing that I'm actually looking for.
Do people actually know what they need? It's not always feedback for basic things, okay? I mean,
Yes, obviously not, but I think with new tools and new technical artifacts that become available, this abstract notion of a need becomes more tangible for the user or for person or organization. And they might actually be able to think about their needs more effectively because they can construct them in this way. That's one of the theories or hypotheses. So if you don't really need to know what you need, maybe you don't know exactly what you need, but you know certain properties. Like, for example, you have a recipe for something you want to cook, you know you want milk, but not exactly which brand. There's a certain matching problem involved, but actually you want milk. Maybe you want a special kind of milk. But you see there's certain levels of abstraction that come into play here, and you can play with it also, and maybe vary to a certain degree.
I guess in marketing, a big part of it is create needs.
Yeah, I'm sure. And I'm not saying that this is now obsolete with the idea that we have. I think this would fit in quite nicely. So if we accept that there might be some document we publish on the web that says this is what we need, we can try to describe this vacation that I wanted to make as a structure of such documents. I would say I need a flight, I need a hotel, I want to rent kitesurfing material. Then I link these documents by saying they have to have certain properties like variants that are unified. Like if I'm going to Egypt, and I need a hotel in Egypt, that's kitesurfing material in Egypt. And I would actually like to be able to commit to the whole thing as a whole, and not buy the flight and then not get a hotel, and not get kitesurfing material. these would be properties that are deemed necessary for this whole system or concept to be useful. Now, this is, in this isolated form, might be an interesting thing to play with, but what we're actually thinking about or trying to get solved is that all of consumers, so this is like a typical consumer, all of retail and all of industry of production uses the same formalism to say what they need and also to say what they have to offer to formulate how things are interrelated. And this vast space is what we call web of needs. And there would be some interesting properties, user-facing properties, like I have a nice vacation, and I tell you about it. You say, it's cool, I would like to do that too. And now I will have to explain to you how to plan something like this for 5 people. I have to tell you to which websites to go and how to get all the information. But if this existed, this would actually be the structure I used, and it would be like a recipe for the vacation I made. And you can just copy it and tweak some parameters, and then it becomes your vacation. And you can mix and match in theory. So if you want to go kite surfing and then go on a motorcycle trip, you combine these to more complex structures. And I don't know where the limits of this would be, but this will also be the recipe to build a power plant or whatever. Or host, for a more realistic example, host a wedding or a concert. Then in this case, the marketplace would look different. First of all, it would be one marketplace. It wouldn't be many marketplace websites or apps. It would just be one layer on top of all of these, where if I need something, I see what's being offered. But more importantly, if I'm offering something, I see what is being needed. This is an essential gatekeeper function currently, held by the search engines and the marketplace platforms. And if you want to have access to these, you have to buy AdWords on Google, for example. Then you can guide people who are looking for something to your website, some of them. But what we're talking about would actually open this up to the general public, let's say. We've been framing this in terms of a marketplace, also because this is the easiest to talk about and everybody understands it. Nobody gets funny ideas. But we're actually not thinking about this only in terms of buying and selling. Obviously, you can also give stuff away for free or use it to get rid of old stuff. But there are other situations that are maybe marketplace-like. I mean, okay, economists like to think about everything as a marketplace, like personal relationships or things like these. But there are just some things that you need partners for. When to get something done, you need other interested people, get them on board, somehow coordinate action. Go climbing, find somebody to play tennis, fix something in your surroundings that is broken, or start a political movement, whatever. So the effects that, or one of the arguments for more subtle effects of this, I'd like to illustrate with this metaphor. This could be a mass of people, maybe at a concert, and this is me trying to get to the exit. Now, everybody knows what this is like. You have to get through all these people, but there's actually more than just you. There are other people who have the same goal, but before you know it, some kind of path forms, and just by seeing that somebody wants to get past me, I'm stepping away and letting people pass. Others, step on this train, and as soon as the people are gone, this path just closes, and it wasn't any effort for anyone, but it got things done. And this is what I think, what we know how to do in person-to-person contact, but we don't know how to do on a societal scale. For example, let's say this is an apartment building, this is me, I want to get something from IKEA, because everybody needs something from IKEA sometimes. And so I would go with, you know what it's like, you don't actually want to go to IKEA. But if you knew that in your building 5 people need something from IKEA, and this person is actually going, it might be so nice as to take the thing from you. And of course there's an app for that, I guess. But it would be, with current technology, it will be an app for just that. And there is kind of a long tail for, let's say, sharing economy applications and things, apps that will never get enough users with just that use case people are solving. But the general idea of collaborating has probably much more potential users. So what are the challenges confronted with? The first is we have to be able to describe needs and offers in a way that machines can understand them, read them, and match them. When we have them described, we need to be actually able to match them. So this is also what we've been trying to solve. Then you have to communicate, and of course there are many communication protocols, but it has also been a field that we've been studying for this particular application, or let's say infrastructure. And a very important part here is also user interaction design. Especially because this is a technology for anything, and you know, we've been using Word for 15 years or 20 years. We know how hard it is to make a good user interaction design with just a text processor, but user interaction design for anything might be even harder. So maybe there's really much more to do here than we have done, and we have yet seen. We talked about this earlier, like user interfaces that could adapt to what you're currently trying to express and give you different user interaction possibilities depending on what it is that you're trying to express. So if you look at it from the different perspectives for the consumers, an interesting question is how to manage needs. You just think about application like your personal information manager, your calendar and notes and everything, as a more general need or interest or intention management tool that interfaces with that of everyone else. Of course, you need good user interfaces, like we said. For people who want to sell stuff, or good use marketplace on the other side, it's also important to do offer management, whatever that is. I mean, there's a whole $1 billion industry doing just that, and it will have to be available to this system too. User interfaces and also matching. And also for the productive industry, would be getting the stuff you need to produce, especially taking logistics and optimization into account, and planning production depending on demand on the one side and also the supply on the other side. Okay, so you get the idea. Most of you already have it anyway. So I want to just say a few words on how we are trying to do this, or how far we've come. So we want to realize these marketplace functions of the problem. Publish your intention, find partners who perform transactions. Our running example is the hotel room, as we know. So this is somebody who wants something. These are people who want to rent a hotel room. And the first question to be solved is, what do we actually represent? So in this case, we could actually be representing people. But there's nothing really important about this person. What we're actually interested in is the hotel room that this person offers. So we try to represent as little as possible in order to simplify things, and also in order to protect the privacy of people who use the system. The next step would be decentralization. again, it's a privacy argument. If there's one big cloud owned by some Google or new company to be created that knows about all the needs of all the people and can identify the people, this is actually a privacy hell, and we don't want to go there. So it has to work in a decentralized setting, which means that I can use, these are like computers or data centers, and I can use different data centers to publish my intentions, my offer. It has to be very simple to create these units, as we sometimes call them, or owner boxes, because I'm potentially publishing many of them. Think of your shopping list. You use it just for half an hour, but you create 20 items, and you're doing this every other day. So this has to be simple and fast. What we need for this is first a standardized CRUD protocol, which means create, read, update, delete, with which you create and manage these objects. Then we need a flexible description language. We talked about this before. Our take on this is to use RDF. That's the resource description framework developed by the Semantic Web community. Basically, it's a data expression language for anything. And these data are always machine readable, and there are standardized tools to create these descriptions, to store these in databases, and we deem them very apt for the purpose. Because you don't have to decide on a data format at design time of this application, but you can at any time come up with a new ontology to describe, for example, fruit, and in that point on, you can describe fruit in a machine readable form. Next point is, if we want independent matching systems, we have to allow world readability for these objects. It means that everybody can download them and see them. So that when we publish these two, matching service can come, whatever that means, and read them, calculate a match, and then send what we call a hint message, so that we can then open a communication channel and communicate. Which led us to select linked data, which is just RDF, so the web technology, on the basis of HTTP. So that every URI that is used in the data is also a URI that you can enter into a browser and get the description back. Maybe as a quick question, would you, as some knowledge of semantic web technologies, RDF, and because I might be going into too much detail otherwise. Yeah. Okay, so I'm trying to not to go too deep into this. What this gets us is independent matching. So these people who are running this server don't have to be the matching experts, and maybe they are focusing on how to most efficiently store your movement offer objects. Whereas these people don't need to be data storage experts, they are concentrating on matching. For the system to work at all times, these nodes or these objects need to be online all the time. So this leads to a further separation, which are what we call owner applications. So these are applications that are separate from the storage nodes, which we call one node, so represents nodes, and these we call owner applications. And you can see that you can use one owner application. Okay, we can't see it here, but in principle you can use any number of nodes with the same owner application. Then there needs to be a standardized protocol for discovery, which is reading the descriptions and sending hint messages. and there needs to be a standardized protocol for making connections. So if I have this message and I know this person can has an interesting hotel offer for me, I can send the connect message, open message there, and then we have the logical communication channel open, which allows us to exchange messages, and after some time, immediately close it. And this would allow us to have a layered communication protocol, because in this communication phase, we could exchange any kind of messages. This is no longer our concern here, but we've been experimenting with chat, of course, which is the obvious thing to do in this situation, but also to create a group chat or make it possible to comment, to leave comments on objects, or to have distributed transactions, or define any other kind of what we call facets or communication protocols on the basis of these connections that can be established. In order for matching services to learn from the past, so from what has happened in the system already, we think that it's important that connection information is actually also world-readable, visible to everyone. So you see, this need has been satisfied by this offer. If we see this 1,000 times, we might be able to deduce it's because of certain properties that they share, whereas other properties aren't that important.
So why would everybody need to be able to see that one offer will be satisfies one need? We need to do some kind of a machine learning, or
the idea is that the history of what has happened can be used in order to improve future matching. And if it's, in principle, I'm not saying that it must be well-readable at all times, but the principal idea is that it is known, it's publicly visible.
who would have possibly a privacy issue that privacy might be useful for other people whose offer needs were missed?
Yeah, possibly. I agree. I'm not saying it has to be always like this.
I think it's right that you use that information to make the system better, but maybe not just by making it available to the world, but somehow use it in your algorithms as a kind of a learning inbuilt into algorithm, so that the aggregates is kept, but not necessarily the individual transactions.
But then I couldn't separate matching from storage and from other aspects of the application. And this would lead to centralization, because then those matches would become better, would have a larger user base, access to more of the fast transactions. And there's also another reason why this could be interesting in this is reputation. I'm not saying that it says I am looking for a hotel room. I'm saying someone is looking for a hotel room. And maybe I'm specifying a few properties about myself that I think are important, or I know that matching services need in order to get matches for me. But I'm not trying to give too much. I know also that there is a possible privacy problem of de-anonymization. If I'm doing this, I don't know, somewhere in Canada in a very not very densely populated region, it might be quite clear that it's me because there are only 5 people with special interest, and for them, I have to something. But for having a reputation system on this basis, I would also have to be, at least I think, I would have to be able to access past transactions, see how they work there. So that's another aspect of it.
I mean, the way I was imagining it was that these things would already at some stage be built into the matching engine, since at this stage you are thinking about let's have many different matching engines. So we don't know yet how they will function, we just make sure that they have access to the information that might help them to build something like this.
Yes.
So
if the users want that. Yeah. So that's also always, I would say, an optimum thing. Yeah, so we are at the anonymity part. There are two aspects to it. One is weak anonymity, if you like. So you don't put all your eggs in one basket. You distribute the objects, represent your intentions on different servers or services, and you don't add any information that would identify you personally. So this doesn't say I need kinds of material, this says somebody needs kinds of material. The stronger version would be, we think, based on onion routing. So we haven't done this yet, but we have looked into it, and we think the implementation that we have now would also run as a hidden service in Tor. So in principle, no reason why you couldn't use strong anonymity with this. So it's really the service provider doesn't know where you're coming from, doesn't get to know your IP address, and you actually also don't get to know where the service provider is. Another aspect, it's like the flip side of the coin, is identity, which is also very important. For example, if I'm running a hotel, I want to be able to prove this is actually an offer from this hotel, Hilton in Brussels, and then from some scam trying to get money from you with that legitimate offer. And therefore I would use certificate systems like they're in use currently. But I can also use it for my private identity as a customer and gather information about my transactions in order to be more trustworthy in the future. So in order to use these existing identity systems, there is a standard that's called Readability, which we have been using. And it's how often you will be looking for standards and identifying what standard it's only to use. Yeah, well, so, okay, maybe I was sloppy. It's not a standard as such, but it's there are some implementation that is possibly becoming a recommendation of the W3C sometime. But the documents are there, it is described, and it's actually a very thin layer over linked data. So it's just a public key and some RDF triples embedding, connecting this public key with a URI. And a combination of the TLS standard with this URI. The TLS standard is used for creating secure connections with the web server. You can send a certificate as a client, send a certificate to this web server. And in this process, you prove that you actually have the private key to the certificate. And that would be the private key, the private key of the key that is identified by this web IP. So you can always prove that you are actually who you say you are, and based on this piece of information, if you actually can prove who you say you are, you can implement access control for different aspects of the data that we create. So in the need, maybe we want to have public when, where, how. Supply, we also have public email and phone. As a consumer, maybe I don't want that. But then restricted access, which means it's only visible to transaction partners. You can have also my invoice address, email, phone, and so on. And there's actually nothing that we have to come up with ourselves for this data. This is about web access control and interfaces with web IP. So as I said, this would enable us to build a trust layer. So if these are my links that I published, I can always reference the same web ID and prove that this is actually me who is publishing these. And when I then interact with some partner, We can later give feedback. There are also ontologies for describing different kinds of feedback. And these feedback would then logically be linked to the identity I was using. So just by using the system, I would create a cryptographical design which can update the network of track records actually, because it's not only my interpretation that's influenced by the transaction, it's also my partner's interpretation. Then, because we have multiple devices to use, laptops, probably multiple touch devices, we need a thin client that can always pull the data from different servers, and it's basically just a very thin layer over what is happening on the web, which we are currently implementing. We'll see this in a bit. And I think I will skip this because it's a little bit too detailed. Just for the general overview, this is what it looked like when there is a connection and there's a message exchange. This is my server where I store my need. This is the server where my partner stores need. And we have objects which are always identified by URIs. So this, they all have their own URIs. Okay. And the objects that I can get from the server here are always signed by me. If I send this open message, for example, this message is signed by me. Then it's signed by this server here. Then it's copied over here, signed by this server. And this way, and if there is a next message, it includes the signature of the previous message, so we get a chain of signed data that cannot be altered afterwards. So it's not easy, or we're trying to make it hard to tamper with the data afterwards. No, we are using many aspects of things that are already around. The difference would be that you have to go to this website first, and then you are contacted by the system. Whereas what we want to do is that you just post your interest in certain type of clothing on the web, and this becomes like a way to contact you based on this interest. So you could actually have the same conversation that you have over this live chat on the website, but you wouldn't have to go to the website. You just say, I'm interested in, I don't know, some kind of special clothing, and you could be contacted by it.
And then the problem will be with selectivity, that you do too many offers for your lead, especially if your lead is complete generic. So you will need to focus on this.
Yes, definitely. I mean,
or at worst, a random selection if you don't have a way to distinguish between all the offers that they all seem equivalent to the system, that the most value that you randomly pick.
But let us consider the alternative. The alternative is that I make a decision in the first place. And I think close, right? Okay. And this is because a lot of money has been put into marketing to make this connection in your brain. We'd like to get this connection out of your brain. I mean, you can have it, but it would be nice if that connection can be made by the system, according to whatever criteria turn out to be the most efficient. Is that true?
The tricky part will be the formula of the computer.
So in a way, you think you see that there are choices. You're more basically, is that you're reclaiming your power, for example, in terms of clothing, if I go, for instance, to Zara and buy a shirt, I know already that, for instance, I think that I know already that Zara actually goes with pieces that go to this destination. So I subconsciously eliminate a lot of things without knowing that. But if I, for instance, use my really abstract information, for instance, a working woman that is 14 years old, I believe in school, this is size, for instance, 10K or 14K, then probably this form of system can suggest brands that really fit this personalized information, customization of choice.
Possibly. I mean, I would hope so.
Because things that come to my mind, you use for this is that you go to a website, you click on a piece of clothing, and then immediately you have already models for a photograph for certain thing. But that model is not you, and they describe that the model is, for instance, the size 6 meter, 10 years, the height of 180, which is pretty basically not average, it's a very high number of parameters. But if you can change that and put your own measurements on that, then actually I think designers who are actually very people to close measurements, you can attract those.
Yes. I mean, I think it's a nice example for your whole philosophy that you need to turn around the market from the offer being central to the need being central. If people clarify their needs, then it's the one on the other side that will have to adapt instead of trying to convince you that they already have what's adapted to you while they don't know you at all.
Yes. So, if you're interested in the economic exploration of the idea, I can recommend a book by Bob Searles, The Intention Economy. So there are many use cases like these sketched out, and yeah, I think they are also talking about the same thing. Okay, yeah, too much information. Okay, so what would be the effect, or one of the effects of this would be that the whole system that we've been talking about would actually reside on a unified data layer. So we offer all these messages that are being exchanged. These can actually be stored in one RDF database. And well, it sounds a bit techy and it's very interesting, but the thing is that you can query this with a structured query language. There's many tools for managing this kind of information. And there's a big difference to how systems currently work. You don't define the data structure at the beginning when you set things up. But these data structures can evolve over time, and you don't have to reprogram the database. You just maybe change your queries, maybe your matching algorithms look at different properties or different data structures. But the technical infrastructure can remain the same. This can also be powerful for scaling this up. Okay, we don't need this. But maybe we should just for a second. So this is the kind of the class diagram of one aspect of what we've built. Here you see the need with certain properties. Just want to draw your attention here for a second. We have for our prototype very basic, that's what it's called, basic need type. There is supply and demand that is put together and critique. These things are always hard to learn. Also need certificate, need or intention. But the use case for do together would be I would like to find somebody to go climbing or tennis. But the critique use case would mean there's something wrong somewhere, this should be fixed. And I want to be matched with people who think the same way, so that we can come up with solutions. I'm sure there are many more useful types that should come and look what is matched with what, but this is what we're currently doing for our basic computer. So, I'm handing over to Heiko, who's going to talk more about the matching. And just so you know, it's like 3 o'clock, so how much time do you get? I think we should start. It's
supposed to go later than lunch and finish in half an hour.
Oh, yes.
Yeah.
Sure.
Yeah, I'm just going to show you a few slides about matching. I've been working on matching since I joined the research studios, and since 3 years now in the studios, and working on matching since then. I'm still struggling, but it's really exciting. The way we see matching is like finding meaningful links between each pair of needs in the system. So currently we are just focusing on pairs of needs, not on multiple needs or combining them and finding pairs. Let's keep it simple. And you can consider different domains of needs. Links can be meaningful in different domains, in different contexts. It depends on attributes like the topic, location, and then location and time dependent and so on. And this can change from domain to domain. And that is actually why we are thinking of making these matching services open, and so that everybody can provide a matching service for a certain domain where he thinks he has knowledge and can join the system and provide a good solution. And these matching services will kind of work in parallel to find optimal links between them. And this matching we currently do based on need attributes like topic, location, time, the connections that have been made between needs in the past. And this matching service will hold something, and the user actually connect each other with their needs, so we kind of know this was maybe a good match, so we can maybe learn from it for the future, and on feedback that can be given on this matching. And like Flo already said, we have these four need types that can be matched, like suppliers matched with demand currently, together as matched with together and and of course this matching is a dynamic process. There are coming needs all the time into the system, and maybe matches have to be found in a very short time because they are time dependent. If you're looking for a taxi, then you want to have a taxi right away. Other needs, maybe you have maybe more time for matching, do more quality matching. And currently we're implementing matching services that provide a score between 0 and 1 to kind of tell you something about the quality of the match. Like if the matching service is kind of sure, then it's maybe more 1, otherwise it's more 0. But yeah, this is also still some kind of problem we are facing. If you have these different matching services and everybody's kind of rating by his own, you kind of know how to compare these numbers. You get into problems here also with these independent matching services. This picture we already have seen. There's this needs published on the web needs nodes, and the matching service is reading them and sending hints to them. This picture shows that the users can also rate these connections that the matchers have made, so that it can be used as information to learn for the future. And here I show you very simplified view of the current architecture of the matching services we have implemented so far. You can actually, if you're interested, download Docker images of our whole application. This is a virtual machine images basically, and you can run it on every computer where you have Docker installed. Very useful. And here's our source code. And so you have these owner applications like your apps or user applications to access the OneNotes and put your needs there. And then comes the matching service and accesses this OneNote, and it has basically different interfaces to get access to these needs. You can either draw the needs, because there are these linked data objects that link to each other, and draws all the needs, and you can also subscribe to OneNote to get informed about needs when they are published there immediately, and get this information like instantly. And then we have this implementation, like we implemented as an actor model, which allows us to cut down different components of the architecture in very small parts and make them distributable to different nodes, so that we can actually have a good parallelization and a distributed service here. And we have built different components, like for example crawlers that call that needs and get these needs in and make descriptions. And then we kind of store these needs in a local database and pass them in internal messaging systems, so that actual matching algorithm implementations can be plugged into the system and can be run in parallel. For example, what we've implemented so far is we call it a real-time matcher. That is a matcher that gets needs as soon as they are published on the OneNote, because the OneNote, the matching service subscribes to the OneNote, informing about new needs, and these needs will go into this real-time matcher immediately, so it can deliver matches very fast. And then we have like what's called a bulk matcher, which is a more sophisticated matcher. It uses machine learning algorithms and is supposed to provide more quality, higher quality of matchings. It may be possible to find connections that are not so obvious from this very fast matching. So we can run different implementations in parallel. It would also be possible with this kind of framework we want to provide for other researchers or other companies that are interested to write their own matching service or implementation and plug it into the system and get notified and profit of the crawling that's already implemented. So we basically have just to provide the matching algorithm. Our infrastructure should be already here. So this first real-time matcher, we used a Solar server that's a basic information retrieval database. We can index documents there and search them. And we just, whenever we get informed of a need, we put that need as a JSON document in that index. And if a new need comes in, then we kind of look what is the title, description, perhaps location, and we kind of make a similarity search of simple terms and words and send out these quick matches. This algorithm. And then there is the second implementation, this bulk matching, this machine learning matcher, which is a link prediction algorithm. It kind of crawls like a lot of needs and looks at the connections between them that have already been made and that was maybe rated good by the users, and try to guess or predict what are new links that could be possible in the future that would also be interesting. And by this we hope we get better quality of matches.
Links?
Yeah, links are interesting. And yeah, we took this special algorithm because it has some nice features. You can actually represent this RDF data model quite nicely there, because you can model multiple dimensions very easily. You can say it has this kind of description, this kind of title, this kind of text, this kind of location attributes, time attributes, and therefore the algorithm can deduce, okay, maybe these other needs would be recognized, or that's why this algorithm is kind of good for this thing, because this fast matching algorithm, you have only the text similarity and maybe, And yeah, this is some visualization we done. What this algorithm basically does, he gets this input of needs. The blue ones are, I think, offers, and the red ones are demands from actual test data we had. And we also had connections between them, that means matches, which we knew were already good, and then we put that into the algorithm, and it finds new connections between these needs. And it is, as you can see, it is especially good at finding connections where already connections in some clusters exist. So here, for example, there's a big cluster. I think it was those sharing network data. I think that's baby clothes or something. But there's a lot of people giving away baby clothes. And then the algorithm finds more in this cluster because he already knows a lot about this. And what we did then, here you see this test data from the sharing network mails we have used to analyze our algorithms or our system. We have like 4,000 needs, that means 4,000 people sending emails to the sharing list. Some people searching for some things, some people giving things away. And it was like 180 categories and like 8,000 possible good connections between them. And then we have written a little evaluation framework where we can put in different algorithms and configurations for these algorithms, and then assess how good the quality of these matching services would be. We kind of delete some of these connections in the data and let the algorithms guess what the connections. And then we can assess the quality of these algorithms, and yeah, we won't go too much into detail here, but we have assessed different algorithms and try to measure the quality of these algorithms. This is an F-score measure between 0 and 1, with which you can like assess the quality of binary classification. Like if two needs have a link or have not a link. And yeah, some algorithms are better than the others, and but unfortunately, yeah, these 3,000, 4,000 needs are only the only test data we have, because it's kind of hard to find good test data. But we are working on getting the system live and actually having people using it, so we can.
Yeah, if in Majorita's data there would be something that could be interpreted as needs, and there's no data.
But it's very work intensive to get them, into this form.
And I suppose so, yeah.
I mean, even that
you
data.
don't have automatic algorithms, industrial language probably don't do that.
Even for that data, for this 4,000 emails, we were going over it manually and trying to figure what every of the 4,000 which fits to every of the other 4,000.
Wow.
It's a lot of work. It cannot be done manually, so we need to get this test data from live data from actual users. And so you get to people use your system in some use case, in some domain.
We need to build a protocol that people actually use it.
And it has to be useful for the people so that they actually really put it in. Yes,
Yeah.
maybe now we can show a really good live, not live data, but video.
Yeah, because we are very experienced in software development, never give a live demo. But it's a very honest demo. In a way.
How it's normally.
Okay, this will take some time, but so you're going to see somebody interacting with the bot, who wrote the test bot. So it's the same thing you've been seeing all along, but on the other side there's a bot. And I don't know, maybe it's not going to work.
Not even the video.
No, not even the video. Very good. Okay, so I said it's very honest because you're going to see a lot of bugs, and you just pretend you don't see them. Okay. We wanted to give you an impression or an idea of where we are at the moment, or what it looks like, what it could feel like. Of course, it could be so much better, but this is what there is. So, some information, how to read the viewer. Somebody is signing up. Also, this really has been done like 3-4 days ago. So this is what it's currently looking like. But we're not video producers. We could have done this much more, shorter and quicker.
Here's you can probably lead time.
Exactly. So really good.
Yeah. And somewhat looking for a software outcome.
Okay, this is the older application. Remember, the need has been posted on the OneNote now, and we're getting matches from the matching service. Some of these matches don't make sense, but this is also test data and not a hi-fi simulation. Looks good, but it's always the same.
It's always the same for all the EKR1.
Okay, so yeah, that's probably the thing to look like. I mean, you say like that, and the whole world says
Nobody wants to.
or maybe better. And basically, this is what everybody knows. This is going to be like a chat connection. And here you see this is first. No, it's actually a third take on what we think the management application should look like. But it's still 9 years away from what we're all going to use in 20 years. Something that will probably be there in some way. So either it's a system talking to us and guessing what we need, or something still looks a bit like what we're used to.
What it means. Nobody wants to talk to you.
Okay, so the debug bot was connected with our mute because that's what it does. It's there because we want to be able to test the system. And
It's a talking bot of Facets.
Mhm.
It's a talking bot that will now fulfill the needs.
yes, and I mean this is not rocket science, but it's kind of fun to. It's also important to have bot on the other side that actually answers, because you use the system differently. You use this for testing. You find out. This is what you always get into with this bot. You start talking to it and maybe you recognize the logic behind this, anyone?
Eliza.
Yeah, exactly. So we can talk to Eliza. And it's actually fun, it's still fun. So I think that's the demo, right?
Yeah.
You can close connections and manage connections and everything. But I think you get the idea, that's the important thing here. So how is this thing? Yeah, and I think we're almost done. So here are some open problems. We talked about some of them already.
spam prevention. I mean, it's obvious. Anybody can send you via the offer when you say, I want to go hiking, and you can't stop it. Something has to happen, right? Yeah, so it could be a malicious spamming measure.
Yeah, because you have several matches are free to implement.
Yeah, and in open system, there has to be some, you can't build in some kind of gatekeeping mechanism in the first place. But something has to be done. How do you compare things from different matches? One of them always says the matching quality is 100% perfect match, and the other one is kind of honest about the matching quality. How do you automatically combine how do you raise the matching quality, of course? How do you do filtering on the one node? How do you do filtering in the normal application? How do you make it generic user interface? And the list goes on and on and on.
I did a few of those.
But these are actually, I think these are interesting questions that are necessary in an open system. Unless you make some design mistake or that's a better idea. It's always possible to so we tried to, based on the proposal that you sent on the mailing list, tried to identify the concepts in the global brain or the offer networks idea with the web of needs, and it's just idea. So we say challenge, positive, negative, alternative, the others, which would also always be in our probabilism. Production rules would be represented in the need content. You could write an ontology that lets you express these production rules, and matching systems could take them into consideration. We're talking about intelligent algorithms to find combinations. For us, this is a matching implementation, and hopefully we can validate the versatile system.
But the main difference is that too much one with one, or really wants too much a whole bunch with a whole bunch at once. Creates
Yes.
kind of a synergy from the coordination between different things.
I think it should be possible with the same building blocks by preparing connections and preparing needs.
Yeah, and our database would have all the material available to have this more sophisticated match work on. So if you start with the simple matches, it will already be useful. If you then have this more sophisticated one based on CRP, for example, it then be added to the one you have.
Yeah, and we've been working on distributed transactions, which would mean I can bring you to the airport with you maybe in the car. So we have this is like two things that are depend on each other, and you can express that you haven't implemented it to our full you're not satisfied with the implementation, but these structures can become more and more complex. And I think this gets somewhere really close to smaller
getting
tools.
to the user with the rules.
Yeah, maybe. We need the user-friendly interface. We call them own applications. They should be independent from the rest. Soft constraints I found. We tried this by embedding Sparkle queries in the root content. So Sparkle is the query language that we use to do web data. There has been this interesting recursive idea of expressing Sparkle queries in RDF, so you can interpret them and use them for filtering. So this is what we did. You send a new print view, you say the color must be either red or blue or green, for example. These were only hard constraints. I admit that it should also be possible to implement soft constraints that confer certain hints over others.
Well, a simple soft constraint is if you are interpreting the data, that you respond to
Yeah, then it might be just a ranking criterion, or I mean, ranking is also a constraint because it's kind of position 1,000 different things. Yeah.
Can I ask regarding this? So you, in the demo, there was kind of the specification of the need was kind of natural language text, like SOFA. And then they have bets, not SOFA. So I would like to get these matches actually, because maybe I need bet, I don't think SOFA. And then you cannot do this with this kind of thing. You need to have certain similarity measures and kind of semantic similarities between words, etc., etc., etc.
Yes. Okay. There's also a lot of future work involved in these soft constraints and filtering and so that you can use abstract concepts or fuzzy concepts for ranking results. I'm not saying that.
Yeah, but
we should not assume that we will have to do all the work on that. Most of these things will be done or are being done by algorithms. As long as you use a standard like RDF that is compatible, sooner or later you will be able to connect this.
Exactly. So I could imagine that there's some kind of specification or recommendation that matching system providers should respect, and all the application providers should respect, and all of a sudden you can do all this kind of software scopes because you understand it better. That's all it's needed. Yeah. There's a lot of future work involved in the things, blockchain, decentralized and autonomous organization. Okay, well, I don't know if you want to make this move, but
it's not, it's already kind of old.
it's kind of not sure if the past is really unchangeable. There has been a hack, but
Can you see this platform in something that could be potentially like companies that can make Siri more intelligent? I mean, when you say, like, if you need to, not necessarily like reading, so I talk about connecting to check my people, or finding, like, search an author. So it somehow matches my needs in real time with what is online. But necessarily it doesn't do it efficiently. It's a very general attempt to match what I want in real time. With a data that is highly basically not organized. Very generally good. Do you think that at some point to offer like the research
if they want to, yes. I mean, this would, if used, this would create a database of the world's least desired offers.
my phone does have it for the second, right? It's really new that we're using my phone.
I think you're putting that in the wrong order. It's not that it looks like Siri is smarter. Siri would be a smarter interface to this thing. Because this thing would be like bigger than Siri. Siri is basically an interface.
Somebody could get smarter and not get everyone. He doesn't
Yes.
understand it. He doesn't catch it Siri or Siri. But somebody gets smarter.
What we could do now probably is use speech to text to create leads. I think we can do this about it. You talk to the owner application that you publish what you say on the needs and what matches. You will lead them back to you. You will say, who can I talk to about philosophy tonight? And you will come back with 3 answers according to the system that you just described. This could work. This would be the smarter interface.
So would be a very nice interface to integrate readability. But the intelligence in the sense should be in the what of these. The intelligence of Siri is basically in kind of understanding natural language and making kind of obvious translations into database queries.
Maybe also getting to know you, filtering the results for you. So, yeah. But,
So there was an article online about you can make friendship with you. Like from a human-computer interaction perspective. That's why I asked the question that I think that maybe this kind of applications and way of thinking can actually make our devices smarter in the sense of actually really allowing us to discover our needs and
But yes,
maybe it's a way, I see it as a concept of device
yeah, and it's a long research program that involves many actors, but yeah, I would be happy if this would contribute to more useful and kind of understanding of the
Well, I think it is essentially what you said this morning also about the web of needs is about not being dictated by the offers that are available, but by having your personal needs the first thing, and this thing would help you to formulate your personal needs, and then the offers would have to adapt to your needs rather than you having to look out for the offer. In one of your papers, you used an example of the marketplace, but then the literal physical marketplace, that means you need something, you have to walk in between the stores and look until you find the thing you need. You cannot advertise to say, I need tomatoes, and then the guy with the tomatoes will come to you. So it's you who has to find the guy with the tomatoes. So what this is doing is it's changing this asymmetry so that now you, with your demand for tomatoes, are as important as the guy who sells the tomatoes.
yeah, exactly.
So it gives you more power, more individuality, more freedom.
Yes, and we would have maybe software agents and helping us do it. Okay,
The bias thing, then you have a...
yeah,
That's a very recent idea of ours.
Technically bias scoring. I mean, with an older application for the bias scoring, it's a little bit.
Because it's how you formulate the needs of the bias to the profile. So you have an idea of how to do it with
It needs agency. I mean, it needs to be able to decide or to do, or I mean, this is a no, you can't go skiing unless I don't know, slow. But it's not slow because of climate change.
No, I mean, Gaia is an agent of a certain need, so the question is how do you get the needs of Gaia into your system?
The way of connecting to ecosystem and sustainability, it's how do you combine with the already existing target, for instance, CO2 emission, and your carbon footprint. So, for instance, as an individual or society, there are a lot of things that need this amount of CO2 emission per year. And then you can basically, if you organize your lifestyle around meeting those demands, and maybe create even a collaborative game with people that okay, how we can collectively reduce our emissions with CO2 of 21, for instance. Global warming, stabilizing it. It won't achieve that goal unless a lot of people actually collaborate with each other and kind of take agency, as you said. So things like that and platforms like this, I think, because it's in the sense that you can collaborate while actually doing with individual, but move for the main of the future global society.
Very possibly so, but
Wasn't it in your criticism that you are worried about, let's say, the industry and you're looking for other people who are also worried about the industry?
sure. But in this case, this would be infrastructure for coordinating probably only human actions. Okay, maybe also machine actions and other things, or my printer orders paper. And coordination of such actions might have the result that the CO2 emission will be because we're kind of playing some kind of interesting game based on this platform or infrastructure. But I don't see Gaia publishing needs and saying you can have it, you can't have it, which is what the system is designed for.
Yeah, so you need a representative of Gaia, which, in the simplest case, let's say that there are, let's say, the United Nations or the World Health Organization or the World Wildlife Fund, kind of formulate a number of needs that the world should be fulfilling in the next 10 years. And for example, one of the things, to make it very concrete, is more forests, more trees. That's a very concrete need that anybody who has a patch of land where something could be planted could put in an offer, and anybody who's willing to plant some trees or who has some seedlings of trees but who needs land could come into contact and the need for more trees would be fulfilled. Okay? So you could create that need for more trees and use the system to find matches.
Absolutely. But it would be a human organization.
Yeah.
Yeah. Putting that on the place.
Yeah, of course.
And then it's perfectly fine. But whatever it does, we'll make it something like that's simple, everybody understands how to use it, and then we can come up with all sorts of usages that we never thought of.
Knowledge sharing platform. Nobody knows what to do with them. They share knowledge and not what to do with them. Yes, it's like exactly it's not like this, but it's a platform that people share knowledge. Share ideas, articles, things like that. And it's supposed to be basically about collaboration, but it's just sharing. And the sharing, if you want to share, you want to bring intention in the sense that it seems that everybody has a purpose, a shared purpose, but this shared vision or purpose is not private. So it's just that they're moving in the same direction, supposed to think, but their actions that they take in that platform, in that case, is not really fruitful in some sense. It's just there. It's something very kind of in a sense of idle things, like it's not accurate. But you, in a platform like this, because you have offers and you at the same time, then you don't just put this knowledge into an entity, because people use knowledge, but the knowledge is simultaneously taken to another label, for instance, application, listening, experience.
Yeah, I would say it's probably transaction oriented more than sharing platforms. I don't know why we share this information. Normally it's, I don't know, maybe heal the world or become more interesting, get more followers, more likes, do better. I mean, this is important goals, but it's not a transaction.
No, but there is a transaction in the sense that it's such as cognitive resources. If I have a question, a problem, if I don't know what the answer is to, that's a need. If somebody else has an answer, it's an offer. If you two can be matched, I will get an answer and I will be happy. At the moment, we have already a kind of match with this with the Google search engine. We could make that in principle using an ontology, we could make that more intelligent. They are working on that on the knowledge level, in a sense, most already exist in terms of matching offers and needs. But it's actually the same problem. It's the same problem whether your need is a need for an object, for a service, or for some information. It's always a need that needs to be matched with an offer of the right kind of information, the right kind of solution.
That is certainly true, but I think we're not doing this because for searching for information needs different technical tools than getting a transaction done. I need to specify the kind of information I need, and then I have to be able to somehow absorb, which we just read. And there's websites that can do that very well. But if there's a transaction involved, then I have to.
I think there's an intermediate category. I mean, you have the category where you formulate a query and you get a text to read, and there is the category where you have a problem that has certain structure. Suppose that I am a farmer and I have grown a particular type of crop in a particular type of soil, and I have had these and these meteorological conditions, and I see that my crop is not thriving, and I would like to know what to do about that.
I agree.
That's, if I type it in everybody, I probably won't find an answer. But maybe a matching engine, if not finding a book that gives a solution, find an agricultural expert who knows about these kind of crops, who could give me the answer.
Yeah, or a person who comes and fertilizes your crops with the right stuff after having seen your crops.
Yeah, that's also what I said in the proposal, that the distance between cognitive needs and material needs is actually very small. The cognitive need is you need to know what's wrong. For example, you need this particular type of fertilizer, and then the material need is get me that fertilizer. But first you need to know. It doesn't make sense if you don't know that it's that particular fertilizer that's lacking, then you can't make a need for it. So the first need is to understand what's going on. The second need is then to implement a solution which requires some material part. So you have an informational part, that is knowing what the solution is about, and then the material part, which is implementing the solution by getting the right service or product.
Mm-hmm.
And it utilizes the information that you have shared already in your LinkedIn, and it provides a profile for you. And then it basically it collects your skill sets, if you have something on your LinkedIn. And it uses that information when you ask a question. Researcher, you can ask a question, and if you meet the researcher, they get hinted. But it seems that you have a knowledge in there's a question you want to answer. So it's like the same thing is happening for everyone sometimes. But again, there is this question of illustration that the agent needs to actually describe what the illustration is. And I think with that comes a challenge of how good we are in terms of formulating our needs in a general sense to be able to be basically accepted or seen as an offer or potential services or provider. Is there a way that you think that you can create a fortified or a generalized framework that people can use like a piece of code? That you can basically, this is how your needs should be formulated in a cyberspace.
Why this one of the open question?
We discussed it a bit this morning, and I suggested to have an overview of needs itself from very abstract and goes into one more concrete. And then you could go either up or down in the hierarchy. If you think about particular need, it may suggest you things that are more abstract. So that you see, actually, it's not really a Ferrari car that I need. What I really need is a sports car, or a car in general, or a vehicle in general, or it can go more specifically. You really want this type of Ferrari. So
It's two directions. Like on one hand, you're seeing an offer moving from, like, in my mind, like, it moves from the realm of abstraction, pure abstraction, and you think that you move something, you want something, and you move in the direction of reality. But the offer is in reality. So they're actually moving in a different direction. So the matcher that you mentioned has to have an intelligent system in a sense that it should be abstract enough, but it's not real enough. So it needs some abstract tools.
Yeah, but there is this continuum. It's really not easy to get this right. Unless you say, okay, there is no continuum, it's just things, and that's it. That's what we're doing for the moment, to keep it simple. But I'm sure there are many dimensions in which you can relax your conditions and you can explore your own needs and desires, and yeah.
I very few servants that I use called source, the basic like is to find a restaurant and then you go to a restaurant. So I use it because I travel sometimes. And the big thing is that if I check in Helsinki, then the algorithm will know that when I come to Brussels, that what type of restaurant I'm at. So that's the reason I use it. But the way they are able to decipher that is first they start with okay, you go and then they learn. So that's how they learn. And then you can also formulate what you require, and it's very easy to pick up restaurants. For instance, it might show me a few tags, like in your card, you like Mexican, you like Japanese, you like Italian. And if I click, say I click Italian, then the next time around it's going to show me this hierarchy of life, right? Then it's going to show me do you like pizza, do you like pasta, do you like something else? And I think it's, I haven't really thought about it, but it appears to me that it's just kind of a, sometimes it tries to predict based on what you have done in the past, and sometimes it's working according to what you actually stated. And then from time to time, this is sometimes annoying, it's just trying to promote me with respect about this creative purpose, trying to show me something else that I didn't actually want to, and I think that one is based on, advertising that some companies and restaurants to be informed. But that's like, there's three mechanisms, and I think it's not like first you do this and then you do that, but of course, in your time? Yeah.
2000.
Yeah, yes.
It might be that some kind of service quality cannot be reached with the system because it's not centralized. It's possible. Maybe, I mean, I can imagine that the combination of all application and matching services kind of use a common data standard and a very intelligent ways of eliciting what the user actually wants. They can get to this kind of interaction. But maybe this will, at least for a foreseeable time, like a blunt tool, but easy to use, easy to understand. Centralization has many advantages for users and service providers. It's just not that we think this kind of having to actually use.
Well, the matching things could become quite sophisticated if they become kind of open source projects where this serious community of programmers work and development, where we know that they can work in without that smart as companies. So the question is, make it sufficiently attractive so that people like that would be tempted to start building these matches. But you're looking a little bit like, maybe you're too democratic in saying like anybody can put in a matcher, or then you could have spot matchers, and what's the problem? You should have some kind of a minimal quality evaluation of matchers.
That's what I meant with open problems. You could have a quality evaluation that results in a shared reputation for matchers, which influences their ranking on different models.
It should be pretty easy if you get a data back of how satisfied the user is with the method that offers. You just order your matches according to that, and people get suggested the matches in the order of the satisfaction.
That can be gained. You write a bot that always downloads Google, and then nobody seems to do the match anymore. It must be a little more sophisticated somehow. But I hope it's working without weak people. Maybe the blockchain is the answer. There's really a lot to look into. But I think we should switch.
No, we wanted to have a pause in between, not have to go for a coffee, so we just go
I just wanted to, it's not that answer.
okay.
But,
So, is it okay 15 minutes pause, we go for a coffee, we can bring the coffee with us?